Okay, hi everyone. So this is the last lesson for light, lesson notes 7.3 on refraction. So the previous lesson on 7.2 we covered reflection, which is the bouncing of light off a surface. Here we are looking at refraction, which is also known as the bending of light. Okay, so let's begin. So at the end of this lesson, you will learn the different terms used, what is the angle, how to identify the angles, there is actually a change in speed as it goes through different materials, and then you also learn about the dispersion of white light with a prism. And then this last part, right, is optional for normal academic. So, but if you want to listen along, you can just let the video play. All right. So let's begin by considering this daily observation. If you put a pencil into a glass like this, you will see that the bottom part looks a bit bent. Okay, see the pencil is here. Suddenly this part bends off before you see the rest of it here. So why does the pencil feel bent or broken? Okay, so this is because of refraction. It's because light actually bends when it travels from the water to the air and then to our eyes. So because the light bends, therefore it seems our eyes think that the object is actually at this area because the light has bent, but actually it is here. So because of this bending of light, it actually appears this way. So this is called refraction. Okay? So yeah, you need to copy that down in case you did not. So this is a diagram that we use to explain or to describe refraction. Again, you notice some familiar terms. This is the normal. The normal is perpendicular, 90 degrees from the surface. Okay, so this is the normal, this is the surface. So the ray that's coming in, the light that's coming in, we still call the same, it's still the incident ray. But instead of bouncing off, we see that the light here actually goes into the second substance. This is known as the refracted ray. Okay, so like the previous time, to find the angle of incidence, we find the incident ray, and it's a ray that is an angle that touches this and touches the normal. So it's this angle here. This is the angle of incidence. Similarly, if you look at the refracted ray here, from the ray to the normal, this is the angle of refraction. So we have incident ray, normal, refracted ray, angle of incidence, angle of refraction. Okay, so you need to copy this down. So why does the light bend? Okay, so how can we imagine this, or how can we try to understand this? Imagine a toy car, okay, traveling along the smooth edge of a table at an angle. So this is the smooth area. This middle part is actually the rough area of the table, sandpaper. So as the car comes in, because there's a change in the surface here, it actually causes the car to turn, because this part of the wheel stays on the smooth surface a bit longer, so it moves faster. So there's this turning here, and you realize that the car has now changed speed because it's on sandpaper, it travels slower, and also it changed direction. And as it leaves the sandpaper, it speeds up, and it also changes direction. Okay, so just take your time to read through this and see if you can understand. Okay, if you cannot, do not worry, you can ask in class again. Just take note that here it was trying to describe that the car has changed speed, has changed direction. Okay, so change in speed and direction for a toy car. So there will be a change in speed and direction for light as it travels from one material to another. So this is kind of like an example, an analogy. Okay, so now here we have two different situations. First, we want to consider when light enters a more optically denser medium. Okay, so for example, this is the incident ray. This is my optically less dense, which is for example, this is air, and at the bottom here, this is glass. So glass is more dense, and so if the light comes in here, how will it bend? Will it bend this way or will it bend downwards? So the answer is it will bend towards the normal, in this case downwards. Towards normal means you'll be closer to the normal than originally. So you realize here it's now closer compared to this one. Okay, so it bends towards the normal. So this is the first example when it travels from less dense to more dense, air 2+. Second situation is when the light enters a optically less dense. So it bends away from the normal. How do we see? So now now glass is on top, air is below. If glass is on top, air is below, and the light comes in this way, how will the light bend? Okay, it will bend in a sense upwards. You bend away from the normal. So you realize now the distance from the normal is slightly further. It's bent away from the normal. Okay, so you see the previous one. This is towards the normal. This is away from the normal. Okay, so now it's your turn to try to practice 1, 2, and 3, and then see, bring your answers to class and we can discuss during lesson time. Alright? Okay, let's move on. So there's also another interesting situation. If you have experience before when you go swimming, let's say you drop something below, in this case your goggles, you realize that the goggles appears to be a bit closer to you. Seems shallower than it really is. Okay? So what is really happening? Why is it that it feels shallower? Okay, so this one your teacher will go through with you in class. We're trying to show you that how the light ray from here is actually bent away from the normal. And so when your eye looks back, it thinks that it is here, but actually it is here. Okay, don't worry, we'll go through this further in class. So this is the summary. We have reflection and refraction. Reflection is when the incident ray, the refracted ray, they lie on the same plane, and the angle is equal to the angle of incidence is equal to the angle of reflection. I is equal to R. Okay, so then we have smooth surface and rough surface. Smooth surface gives me regular reflection, rough surface gives me diffuse reflection. Then for refraction, we know it's the bending of light. And this happens when it travels from one medium to another of different optical density. Okay, so when it travels to a more denser object, it bends towards. When it travels to a less optically dense, it bends away. So this is what we went through just now. Okay, so we move on to the next part of the notes. We talk about the dispersion of light. So if you have seen before, when white light shines through a prism or shines through water, you realize that it splits into the colors of the rainbow. So what are the 7 colors of the rainbow? Can you remember? Okay, so I hope you can remember. These are the 7 colors: red, orange, yellow, green, blue, indigo, violet. Okay, so you should know this. If you do not know, I think it's still good to remember. Alright, so let's look at the picture. You can see better. So this is a prism. In other words, it's a triangular piece of glass. It's not your rectangular piece, it's a triangular piece. And so what happens? Say I have a beam of light traveling through a prism. So this is the light, incoming light, the incident ray. When it hits here, it bends. And you realize that different colors bend at different angles. So in this case, your purple, or should I say your violet here, actually bends the most, while your red bends the least. So the colors actually splits up. Okay, so this is because the different colors of white light bend towards the normal through different angles when entering and leaving the prism. So when it enters the prism, it splits. As it leaves the prism, it splits further. So you have here a spectrum of 7 colors produced. So this whole thing, we call it the dispersion of light. Okay, so question, which color among the red, orange, yellow, green, blue, indigo, violet, which color travels the slowest in glass? Okay, I'll let you get some time to think, and then write down your answer. We will review it in class. So this has got to do is how much the light has bent. Okay, I'll let you figure out which one is the slowest. Okay, so now is the part that is optional for normal academic. You can choose to pause the video. If not, it's good to continue and just learn something more. Okay, so for express students, you need to learn this. So this is like a color like chart. You can see that the 3 main colors on the outside, and then when green and red overlaps, you have yellow, and when the three colors combine overlap, they have white. So what is this trying to show? Okay, the first thing you need to recognize is that the red, green, and blue colors are actually the primary colors. Okay, they are the first primary colors. And if I mix the primary colors, you become secondary colors. So for example, green and red forms yellow, blue and red forms magenta, and then green and blue form cyan. So these cyan, yellow, and magenta are considered secondary colors. And then if you add all three together, you'll form white. Okay? So why is this useful? It is interesting because depending on the color of the object, you see a different light. So what do I mean? So if I shine white light to a red ball, blue ball, and a green ball here, when white light reaches here, what happens is that the light, the red ball absorbs all other colors, but reflects the red color. So when I see it, I see only red. Therefore, I can tell this is a red ball. So if it's a blue ball, you absorb all other colors, but reflects only blue light. So when I see the blue ball, I see only the blue color, I know it's blue. So similarly for green. So it reflects their respective colors and absorb all other colors. Now what happens if I shine only red color instead of white? So red color is a primary color, it only has red. So if I shine onto a red ball, nothing happens, it just reflects back red because nothing gets absorbed. I see it as a red ball. But under red light, if I have a blue ball, what happens? The red light hits the blue ball, it doesn't get reflected, it gets absorbed. So what will I see? Will I see blue? No, I will actually see a black ball here because no light has been reflected. So it is only black to me in the eyes, even though it is blue. Okay? So similarly for green, because red light hits the green ball, it gets absorbed, it's not reflected, I see a black ball. So under red light, if I shine on these three balls, I only see red, black, and black. So under red light, only the red ball reflects the red light, so the other two balls will appear black because the red light is being absorbed. Okay? So if you want extra information, this is actually quite interesting, but this can be very complicated. You can look through this and see whether you can understand. If not, I think it is fine. Just jot down your questions, come to class, and we will go through it. Alright, so this ends the lesson for the 7.3. Hope you understand it, it's not too difficult. We will go through in class. Okay, thank you for watching.